Hello, and welcome to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit industry. Joining me today is Scott Clays, Senior Technical Marketing Engineer with Siemens, to discuss integration between PCB design and PLM systems. Why is this important? You may ask. I'll tell you, optimizing product design requires integration across the entire development process, from defining requirements, architecture, to design and manufacturing. We often talk about things like ECAD and MCAD integration, or even electrical and electronic. But let's dive deeper into what integration with PLM can do for us as PC designers in the printed circuit world. Scott, thanks for being here with me. Can you give our audience a brief introduction of yourself?
Thanks, Steph. Hi, I'm Scott Clays. I've been at Siemens EDA as a technical marketing engineer since 2022. I'm an electrical engineer and I specialize in ECAD to PLM integration. I have 18 years of expertise in this field. I learned PLM as an applications engineer at PTC in the 2000s after working in the industry for many years as a designer and CAD administrator. Since 2007, I've focused specifically on implementing ECAD design data in PLM systems, and I've worked both as a consultant and with various companies to integrate ECAD with PLM solutions.
Awesome. Well, you're definitely the perfect subject matter expert to dive into this topic. So the first thing I'm going to ask you, or for those in our audience who don't know, what exactly does a PLM system do?
Well, that's a very broad question, Steph. So let's take it apart and into a few pieces. And I'm going to try to approach this from the PCB designer's perspective. Having been one myself, I understand that this topic can be complicated and confusing. So the first thing to understand is that we're trying to use what is referred to in the industry as the digital twin concept, where we represent the product digitally within a system, including every single part, specification, document that describes those parts and defines the product in an electronic format. So in order to accomplish this, we would like to do more than just data management of our design data. We want to keep the information stored in such a way that we have access to that data and have enhanced capabilities to use that data. So there's several different core structures that apply to PLM. There's the data management layer where, of course, we have the single source of truth for all of the information. In addition to that, version control, which we've done ever since we've done design in a paper format. However, in a PLM system, we add an additional control mechanism to our design data, and that is configuration and design management itself in terms of the state of an object inside of the PLM system. When something is released, it becomes locked and no one can touch it or change it. And that's a very key concept to understand, and probably the most important thing, I think, personally, to understand and comprehend with what a PLM system gives you. Once something's locked, it's stored there forever. It's not going away. And if you ever need to do a change to it, you have to revise that item and then move it to the next revision, where it then is unlocked and is work in progress, where you can continue to work on it. That's one of the key pieces. There's also many other things as far as management is concerned, for automation and tying into workflows, assigning tasks to different folks within the organization, and then implementing integrations with both your design tools, but also with manufacturing systems, supply chain interfaces, quality management integration. All of these things become much more readily available and possible once you've got your design data into a system that will allow you to take the approach of evaluating it and viewing it and essentially managing it in an organized format. It's also important that this format is very consistent across, if I'm working on a screw or I'm working on a complete product. The consistency within that management is, we're always using a common type of release workflow usually, or a common type of new part introduction workflow, the two that we most commonly see in the industry, in such a way that everyone in the organization then becomes familiar with how it is that we engage and manage that design data itself.
The biggest takeaway I get when I hear the term PLM system or the acronym PLM is basically control. The ability to control your data. And I think that's the biggest thing when you think about a design team in general, is controlling the data. That leads me into the next thing is, many designers worry about a PLM integration that might disrupt their creative process. How does integration actually enhance rather than restrict design freedom?
So I can understand this concept clearly. when I've worked in the industry in the past, it seems that bringing on additional pieces of data management such as this will increase my workload. So what we want to understand is that the implementation of these types of systems allows your design data to be accessed earlier in the design process by more folks that would be interested with it downstream, such as manufacturing or purchasing, or even your colleagues when you're doing some form of design review in the PCB or even pre-PCB, the actual circuit design aspect. You could be doing a design review with your colleagues by checking your data into PLM, notifying him that it's there, and having either an online or offline design review of that data by pulling up the information and looking at it from that system. This often also frees up the designer, and if the designer is a separate person than the electrical engineer that's designing the schematic, to continue doing his work while the evaluations are happening, effectively freeing up different aspects of the design process so that we can run some of them in parallel as much as possible.
When you think about controlling the data as well as reusing what data is available to you, already released that's locked down and controlled, leads me into the realm of design reuse. So let me ask this. What happens when designers need to reuse elements from a previous design? How does PLM make this easier?
The design data itself from a existing design is essentially released or possibly work in process, locked into the design system within PLM. Well, we can use a good PLM integration connector to pull that design data out of PLM. And when we do so, we can reassign the design data to new part numbers or objects within PLM and pull that data out and reset that information on the PLM objects into the design data so that we effectively create a new part number or a make from situation from that existing design. It's a very common use case within PLM systems and the electrical engineering area, and allows us to start from an existing point that we know is good and perhaps either branch off or make a new product that accomplishes the same tasks in certain aspects as the one that has already been tried and tested in the past.
As I said, when I think of PLM, I think of control and being able to access controlled release data, especially data that's already approved and out in the industry. I've experienced in my earlier stages of my career, what happens when you're using a server as a place to house your data versus a true PLM system. And that really opens up Pandora's box, or the potential for opening up Pandora's box when you think about who can access what and who could change what without actually notifying all the other key stakeholders in that. So when I think about potentials that could go wrong, we've all experienced the dreaded, what version or what is the latest version? Which one are we going with? And believe me, I've been on a team with senior level engineers where we've actually fabricated the wrong version board. Why? Because one engineer decided to make a change, and the change he made, instead of pulling it from a PLM system, which we had in place at this particular company, he pulled one from the server, made a change, and then sent the Gerbers right to the supplier, skipping our process, and everything fell apart. Could you tell me, how could PLM integration solve these problems for designers?
Well, the important concept here to understand is one of the points I touched on earlier, and that's where we control the state of an object, or status as it's also known. That's actually a good side topic that I should bring up. The verbiage and the terms that are used within PLM often intersect with ECAD and MCAD tools, and you have to be careful when you're talking about some of these terms to make sure that you're clear amongst your colleagues when you're having a discussion as to what you're exactly talking about. So sometimes you have to add on some additional adjectives there to help everyone understand. So when an object is released, it means no changes can be made to it. So a good PLM integration will take out that existing design maybe to allow you to view it, but you can't push it back in and change it. So the intention here is that state of the released object is what purchasing should be using, which of course, this encapsulates one of the things we've been talking about as far as downstream access to data. Purchasing should be pulling the information that they're buying from the PLM system via a process that they have been taught. So there's some training involved here with using PLM systems. Generally, what I've found in my experience now is that a lot of companies have this understanding. It just seems for some reason that the PCB guys and the electrical guys are a little bit behind in that space. The important aspect here is that if you do need to change it, you cannot do so without going into PLM and pushing the revise button. Revise then makes a copy of that design and changes it to a revision B, for example, and changes the state to work in process. And now you can do your changes to it. Again, you probably shouldn't be purchasing until it's in a released state. So it may be that the setup in PLM typically is such that someone can't order anything. They can't even see it unless it's released if they're in the purchasing department. That's a possibility to set up that type of configuration in PLM. So there's a lot of orchestration that needs to happen here to clearly outline what the pieces are that need to be put together in the PLM system, along with the workflows with respect to the designers and the PLM system, so that we're good and efficient at keeping these topics concise and handled in such a way that mistakes like you're talking about don't happen.
When I think about controlling your data, a lot of it has to do with company culture, the internal culture. Do they buy into a PLM system? Do they buy into the process and guidelines that are in place and they follow them? You can have many of great process documents, checklists, but if you have a culture that doesn't follow it, then it doesn't matter what you have in place or what tools you have in place. Company culture can make a difference. But if you have a good culture that follows the process and you have a strong PLM system, it's amazing when you think about the different domains collaborating and how effective and how efficient that can be. That leads me into my next question, Scott. So how does integration help PCB designers collaborate between the different disciplines when you think about electrical or mechanical or MCAD and ECAD, especially for exotic type designs such as Flex and Rigid Flex?
This area is under a lot of scrutiny right now at Siemens EDA. The PLM system itself can essentially store and vault any form of information that you want. So specifically in the ECAD, MCAD space, we're looking at some more efficient ways to handle the transfer of IDX design data. This area is what I call a top of a pyramid activity that requires a lot of preparation and underlying infrastructure to be built out. You need your libraries to be structured in a way that's understood both in the ECAD side and the MCAD side. It requires implementing best practices for library control and a really deep understanding of using essentially two authoring tools to work on the same design. So this is kind of a difficult area. The way that it helps is the PLM system can be the repository for knowing that the latest information is there, and I go to that location within PLM on that design to pull that latest information. I think in the near future, we're going to see some tools potentially that assist us with that in a tighter structure so that we'll be able to be notified when changes have happened in that space, and we won't have to worry so much about throwing information back and forth through a shared drive system or through any other mechanism.
The biggest goal is to maintain the integrity of the data at all times at the highest quality. When we think about all the engineers today within the teams, what they got to cover and what they have to absorb into their day-to-day activities, what's the learning curve like for PCB designers and other team members that have to interface with PLM, within their company elements? When you think about PLM integration, and then what changes in their daily workflow in doing so?
The important thing in terms of the learning curve is, in my opinion, to make sure that as an electrical engineer or a designer or someone in the electrical space, that you try to take advantage as soon as you can of the training materials and functions that are available to you through your company, even when the MCAD guys are coming up to speed. If you're not actually implementing PLM in your ECAD space yet, there's a lot of training that is done in that space. It's a good idea to understand how PLM works, how you navigate through PLM, usually some form of web browser-based environment. And the picks and clicks can be confusing because there's a lot of different things going on. But really, it's just like any other tool that you're doing that's web-based, where you take a little bit of training, in my experience, until you actually need to use it and have to navigate and find something personally yourself, or have to determine where someone else's design is or something like that. You really need to get hands-on and into the PLM system yourself before you'll understand it really well. Now, the electrical space for storage of assemblies has some complexity to it. So it's always good to participate in training, but also try to bring up to the folks in the training environment that, as an electrical person, you're going to have an entire assembly that you're looking at, not just a design that's stuck on a part, which is the simplest implementation that we see mostly in the MCAD space. So while the curve is somewhat short, you do need to exercise it and learn about it a bit. When you're proficient with a connector, you can actually use a PLM connector to automate a lot of the processes. And Siemens has some good solutions for us there. The processes for pushing design data into the PLM system in a very uniform and consistent way. I have taught classes in that space that last 3 or 4 hours and then supply some training material, and a user is good to go in pretty short order. When a design is first implemented from the PCB assembly side and pushed into PLM, it takes 10 to 15 minutes to set that up and attach to all the PLM objects and get everything established. But after that, if you want to check in again later on, you push the button and go get a cup of coffee. Of course, there's latencies always dependent upon network connections to PLM and in other areas that only IT guys can control. But in general, it's very quick in terms of the amount of time that it takes you to handle those things.
I think the biggest thing is understanding and mastering your tool. It's no different whether you're designing a board or within your ecosystem. You got to learn to master your ecosystem, and a PLM system is part of your ecosystem. How do you manage the data and keep the integrity intact of what you're manipulating? For our technically minded listeners, could you explain how design data flows between PCB tools and PLM? What that would look like, or what actually happens behind the scenes?
So a good integration performs several tasks for us so that we don't have to manually push around data into the PLM system. So first, it will create a standard and consistent data model of new PLM items. Different PLM systems have different items. Usually there's parts, sometimes also documents. The standard data model will allow separate management and version control of the design data, the assembly data, and the PCB data. So it will store all of the output files in their respective PLM items. And that means that there's a complete package of the design information, like zipped or possibly an EDX file that's stored on the design item inside of PLM. And then fabrication information is stored on the PCB item, such as Gerbers or ODB++, and assembly data is stored on the PCA item. We can also implement configurations to allow additional items to be stored. And there's always some time spent with discussing with customers how they want that to happen. And at Siemens EDA, we're looking at expanding some of the capabilities there as we move into the future, because we're certainly aware that there's a lot of other data that can be associated with your designs that you may want to vault in PLM as well. Regardless, you can always push anything you want manually into your PLM system and control it. And I would always advise doing that if there's not an automated way to do it, because that, again, puts it under control and gives access to the entire ecosystem in your company. So all of the items that are created in PLM are linked together and tied together in such a way that makes logical sense. For example, the PC board itself shows up on the bill of materials underneath the assembly. The different files are attached to those different objects. And then PLM metadata is also read from PLM objects and can be pushed back into your design tools. So if you wanted to populate your title blocks with name, number, and different pieces of information that your PLM system is also storing, there's efficient ways to do that as well. Of course, the biggest item that we generally talk about is that bill of materials itself. So it's presented to the designer for approval before you can push it into PLM. So it's giving you a checkpoint if it's a good system. And then once it is in PLM, most PLM systems have methods for comparing bills of materials. Even if the bill of material isn't released, You could compare it to the last iteration of the bill of materials that you checked in, or go all the way back to the last one that was released and see some differences that will show up on the screen for you, and you can tell exactly what you've added and removed. And it's another way of qualifying your design to make sure everything is there. Of course, purchasing is sometimes interested in that area as well, and they can also perform those types of things. Once that data is into PLM, they don't have to come to you and ask for you to provide a Excel spreadsheet of the differences between the Rev A and the Rev B design.
That data is already there, as well as the ability for supply chain to parse the data and navigate like where used, where they can do strategic buys, and how like maybe a shortage in one part can be affected and rippled in what systems or which assemblies. It's very efficient. And when you view a PLM system for truly what it is be able to manage and control the data. It's amazing why so many people still today don't really use a PLM system. Instead, they're still relying on servers and spreadsheets and just a manual or legacy method of operating. It's really scary. But this introduces the question of capabilities of a PLM library integration. What aspects of this are important?
Well, this is a really important and very broad area, so I'm really going to only touch on it here. We could spend another hour and a half on this specific topic. So I'm sure we will do that in the future, and you can look for that potentially. So the ECAD space has a lot of complexity in its libraries that honestly don't mean a whole lot to PLM systems. There's things with symbols and footprints and pad stacks and whatnot that we don't necessarily need to push that information into PLM. So we might be interested, of course, in cost and availability, and probably an odd attribute or two, such as RoHS compliance or something like that. But low-level data management of ECAD data is best done usually in a comprehensive library management system, such as the Siemens EDM system. The only requirement for creation of a bill of materials in PLM is the existence of a representation of that part, resistor, capacitor, integrated circuit, even a board as a part, in the PLM system, and then it can show up on a bill of materials. Of course, we transfer in reference designators and other attributes that are appropriate to a bill of materials, but you don't have to do anything more than that if you want to start building a bill of materials inside of your PLM system. However, library complexity, even though it is complex, we may want some of that information to be transferred bidirectionally. So for example, typically if I'm doing a new part introduction flow, the information that's provided will come through a workflow potentially from the PLM side, could also be kicked off through EDM. There's a couple of ways to do it. So you're going to have some approval points and some notification systems there. Qualifications from component engineering may want to be established. The manufacturer that produces that part might need to be approved by purchasing. So typically a workflow wraps around this whole space. And the tool itself that synchronizes this data should be then capable of searching for a part number in both systems, the ECAD library as well as the PLM system, and telling you if it exists in one or both. If it does, it should do a comparison. Oh, by the way, when it does the search, maybe you want to do some global searching. So you might be wanting to use wildcards or look at classification or even subclassification of parts. Maybe you're not exactly sure, if it's there and in what the search parameters should be. So good connectors assist you in this area, so you're not having to brute force all of these searches and do these steps manually. So once you search for that part and it's done the comparison for you, there's usually some form of configuration work that's been done to establish I should make a new part in my PLM system by telling PLM to create the record. PLM gives me back the part number, which I can then push into my ECAD library. The ECAD library might typically push something like a tolerance and the RoHS state and the value, other pieces of information, whatever is critical for you. And then PLM can supply back the state of that item. Just like we had in design, there should be states on your library parts within PLM as terms of whether they've been reviewed and are released and ready for purchase because they've been approved.
One thing that we haven't mentioned so far, but is key, is ITAR control of the data as well as who can access what. And this is what I really love about the PLM system, is it allows you to be able to do that strategically. If you're on a global team, maybe you have team members on the other side of the ocean. I think PLM does a great job in helping manage that data to who has X what.
That's a good point, Steph. We haven't really stressed that too much. Typically, a PLM system will have hundreds potentially of products in it, and not all engineers necessarily need to access all of those products. In certain cases, we set up a library where we want to share either circuitry or parts. Usually a library is a shared element that everyone can have access to. But a product can be limited to only those that are on the design team, such that no one else can see that, especially if there's ITAR constraints or some medical devices have HIPAA requirements on them and only certain team members can access those. There's a lot of moving parts here that PLM helps us with quite a bit in that space. So this is a task that typically falls to a great admin team in a company that's setting up that PLM system, or sometimes I've seen external resources help out companies do that as well. And it can usually be orchestrated in such a way that there's some good boundaries between what the different areas of expertise are and how we establish those permissions so that the different types of users that need access to libraries can perhaps view them, but only the librarian can view and edit. So all of that capability exists within these systems and helps quite a bit in maintaining good standards of practice within the actual creation and maintenance of the data itself.
Like I said, I've experienced that firsthand, especially with all my experience in the mil-aero industry. And you think about large ecosystems that implement the PLM system and have heavy integration, and especially having team members globally, how does that respond? So what advice would you give, not only just to a PCB designer, but engineers whose companies are planning to implement PLM integration?
Sure. I think I touched on this already, but don't gloss over waiting to take training classes and learn the PLM system in those classes. I highly suggest shoulder to shoulder with the MCAD folks. There's processes that MCAD will have, such as design reviews and release and new part introduction, that are not too dissimilar from what an ECAD person will need. However, there could be different approaches that are needed because of the different domains. You do have librarians and things like that have other needs than in certain areas that can be of use there. So try to reuse those processes as much as you can. And if you see something that's not being addressed in terms of the ECAD space when you're in those training classes, raise your hand, say something about it, and be a bit proactive. I've seen some engineers really take to heart the implementation of PLM systems and become quite familiar and expert in this area. And it can indeed be an enhancement to your career capabilities as well.
Looking ahead, what exciting developments should PCB designers watch for in integrated design environments?
I think the ECAD to PLM flow on library synchronization is, with supplier information being pushed all the way through that path, is something that's pretty exciting that we're starting to see happen, along with the implementation of 3D models on those parts. So I think we're going to see some expansion where we're not just passing metadata from one system to another. We're going to be passing a lot more feature-rich data that's usable in that ECAD to MCAD space, as we talked about a little bit earlier.
I agree. I think if I was to give any advice, my advice would be is adapt to the ecosystem of a PLM system and master it, no different than you would master your tool, because it's just another part of the process where you house the data and how you control it. Especially, when you first mentioned about don't be hesitant to take the training, get involved and learn the system as quickly as possible and then master it as much as you can. Before we end, what's one thing you would want PCB designers to remember about a PLM integration?
You're providing your downstream customers, your colleagues, in fact, with earlier access to your design information. This enhances parallel design activities and helps your company be more successful.
That is well stated and perfect. I wouldn't say it any other way. Awesome.
Thanks, Steph.
Yeah, I think that's all we have time for today. And I want to leave it on that note. I want to thank you for your valuable insight that you shared with not just me, but the audience.
Thanks, Steph. It's been great speaking with you today.
Yeah, awesome. And to our audience, if you enjoyed this discussion, please tune in to our next LinkedIn Live discussion on integration, where we'll have highlight the 5 key digital threads that connect across the electronic system design process.